everyone. Welcome to Chapter 12, the very last chapter. Congratulations for making it this far. I am really proud of you guys. I'm hoping that statistics is making sense or beginning to make sense to you. And if, let's say, you've made it this far, but you're not pleased with your grade and you want to repeat the class, well, obviously, I'd rather that you get it the first time. Not that I don't like you, but it's time to move on. But if you do need to repeat the class, then don't feel bad about it. It doesn't click for everyone the first time. And I will be more than happy to be your statistical guide in another semester. But let's assume that you're all doing really well in this class, and now it's time for that very last chapter on correlation and regression. And much like the previous chapter, correlation and regression is all about relationships. But unlike the relationships we studied in chapter 11, where we analyzed frequencies, in this chapter, we're going to be looking at relationships by analyzing scores. All right, so we're going to look at two or more variables, and we're going to look at the scores, the numbers within those variables, and use those scores to determine if two or more variables are related to each other. So one of the first things I want to do now is explain the difference between correlation and regression. One builds on the other. The first one that you need to know about is correlation. And just to give a quick definition for correlation, it refers to a set of procedures that we use to determine if two or more numeric variables are related to each other. So let's take this apart. First of all, there has to be at least two variables. Right? There can be 3 or 4 or 5. If we have just two variables, it's called bivariate correlation. And if we have 3, 4, 5 or more variables, then it's called multiple correlation. The other thing that's important about this definition is that your variables have to be numeric. In fact, they need to be measured on an interval or ratio scale of measurement. Now that's different from chi-square, right? Because when we use the chi-square contingency test to look at relationships, well, one, we were analyzing frequencies, but two, the variables themselves were categorical. So they were nominal or ordinal variables. With correlation, our variables are interval or ratio. All right, so we're going to use the scores on two or more variables to determine if those variables are related to each other. In the process, we're going to end up calculating an R value. All right, so the R stands in place or represents the word correlation, right? Now, for regression is also a statistical procedure, but this time you're using these procedures to predict values of one variable from known values of one other variable. That's simple regression. All right. If, let's say, we were using values of one variable to predict values of, let me rephrase this. If we were using values of several variables to predict one other variable, that would be multiple regression. Okay, so simple regression involves just two variables. You have one variable that you're using to make a prediction, and the other variable is the variable you're trying to predict. Right? That's simple regression. Multiple regression is when you have multiple variables like A, B, C, D, and you're trying to predict one other variable. So let's say you're trying to predict E. Okay? So we will go over both procedures, but the important fact that I want you to understand with regression is that if your variables are not correlated with each other, then why on earth would you use one to predict the other, right? It makes no sense. For example, we know that height and weight are correlated with each other. There's a relationship between them, at least during the childhood years. All right. So from birth until about 16 to 18 years old, basically, the taller you are, the heavier you get. Now, it's not a perfect correlation. There's not a perfect relationship there. We know lots of instances where that breaks down. But for the most part, it's true. Now, what if height and weight were not related to each other? Would it make sense to use one to predict the other? No, of course it wouldn't. You would just be guessing, right? If they're not related at all. But it's because height and weight are correlated, we can make predictions, such as, well, if somebody is, I don't know, let's say 5 feet tall, how much should they weigh? If somebody is 6 feet tall, can we predict what they might weigh? All right, so two variables have to be related, that is correlated with each other, in order to take advantage of regression. If you try and use regression on unrelated variables, the equivalent of what you're doing is guessing. Okay? Right. So as I mentioned before, we're going to start off after we cover correlation in this chapter. We are then going to move on to regression, and we're going to look at simple regression first. So we're going to use values of x, one variable, values of x, to predict one other variable, y. Okay? And then we're going to finish off with multiple regression, where we're going to use two or more variables, such as x and y, to predict a third variable like z. Okay?